Hello, Steve Weaver here with a demo that shows how Terraform and IBM Turbonomic can be used together to reduce infrastructure cost while maintaining performance across your organization. As cloud usage scales, so does cost, often in ways that aren't efficient. Many organizations provision virtual machines based on guesswork or peak demand, but then fail to scale down when demand decreases. This results in performance risks, wasted compute resources, bloated cloud bills, or underutilized infrastructure. The Turbonomic Provider for Terraform is a plugin that enables HashiCorp Terraform to interact with Turbonomic, which in turn communicates with cloud services such as AWS, Azure, and GCP to optimize your cloud infrastructure. By integrating the Turbonomic Provider for Terraform into your infrastructure as code, you not only gain intelligent optimization recommendations, but you can also apply those changes automatically either using Terraform runs or safely in Turbonomic. So let's begin the demo by viewing our Terraform code in GitHub. We've specified the Turbonomic Provider and we're using it to both provide recommendations on sizing for our EC2 instances and to allow continuous validation checks in HCP Terraform. We're also using the AWS provider to define and manage AWS resources, in this case to launch and configure an EC2 instance in AWS. Before we define our AWS resource though, we're going to add a Turbonomic data source. The Turbonomic Cloud Entity Recommendation is a specific type of data source provided by the Turbonomic Provider. It's designed to get scaling recommendations for cloud entities from your Turbonomic instance, which will then be applied during a Terraform apply command. When the provider does not find an entity with a specified name, it returns a null value. In such cases, the default value T3 nano is used. So this typically occurs during the first run of a Terraform apply. The AWS resource block is then used to define and provision the actual EC2 instance, using the recommendation from Turbonomic defined in the data source above to identify the instance type. In our case, since we haven't run a Terraform apply yet, we can expect a T3 nano to be provisioned. Finally, you can use the HCP Terraform continuous validation feature to ensure resource configurations are consistent with Turbonomic recommendations. The health check runs periodically every 24 hours, and it can be run from the continuous validation page in HCP Terraform. Because we've configured the Turbonomic Provider to fetch Turbonomic recommendations using the data source we defined earlier in the script, we can add a check block in our code to perform an assertion check on the EC2 instance using Turbonomic recommendations. So here you can see we've added a Turbonomic consistent with recommendation check assertion. Okay. Let's take a look at the result of our initial run in HCP Terraform. In the Terraform plan section of the Run UI, we can see that we are indeed creating an EC2 instance in AWS, and it's defaulted to a T3 nano, as expected based on the behavior of the Turbonomic Provider. With the Terraform apply finished, we can see that the resource has been created in the apply stage. We can verify that the EC2 server has been created by checking in the AWS console. And there it is. And again, as expected, it's a T3 nano. Jumping over to the IBM Turbonomic dashboard, we can see that Turbonomic has discovered all of the resources in our AWS account and is actively managing them to see if they can be optimized based on real-time and historical data. We have 3 virtual machines active, and we can click on the chart to drill down to see the details. Immediately, we can see that we can achieve savings by changing the instance type of our example virtual machine from a T3 nano to a T3A nano. We have 2 options here. We can execute the action from Turbonomic to update the instance type, or we can go back to HCP Terraform and initiate the Terraform apply from there. In either case, we'll bring our instance in line with Turbonomic recommendations and avoid any potential drift that may have occurred from updating the instance type manually. Looking into the data in a little more detail, we can see that the T3A nano provides the same level of performance as the T3 nano, but at a reduced cost. Let's go and perform the Terraform plan and apply from HCP Terraform. Drilling into the Terraform plan this time, we can see that the Turbonomic Provider has automatically updated the T3 nano instance type to a T3A nano, in line with the recommendation we saw in Turbonomic. Okay, we've applied the change. Let's go and take a look at our AWS console to make sure that the change has been made. And yes, it's there. The T3 nano EC2 VM has been upgraded to a T3A nano. Let's verify that the change has been picked up by Turbonomic. Drilling down into our virtual machine inventory, we can see that there's no action for our example VM this time. and taking a look at the details reveals that the VM has been updated to a T3A Nano as expected. Finally, let's go back to HCP Terraform to check on the assertion we added to the code. This will show up in the health section of HCP Terraform under continuous validation. Our assertions will be checked automatically every day by default, but we can also run them on an ad hoc basis by clicking on the Start Health Assessment button. As expected, our check passes successfully. We've optimized our infrastructure. So that's it for this demo. We've seen that leveraging the Turbonomic Terraform provider with HCP Terraform provides significant benefits by embedding continuous optimization directly into our infrastructure as code workflow. It transforms the way resources are sized and managed from a manual, guesswork process to an automated, intelligent one. Thanks for watching.